In this lesson we're going to look at how to deal with questions 4, 5 and 6 from the Unit 2 Specimen 2 Higher NAB. So these are basically all the integration questions. So the first question is the curve with equation y equals x squared bracket 2 minus x is shown below. Calculate the shaded area here. Now the limits of integration are 0 and 2, 2 being your upper limit, i.e. it's furthest right, and 0 being your lower limit. So we're going to integrate this between 0 and 2. So I'm going to write that out in proper notation. Integrate with respect to x between 0 and 2 in your upper limit here. Now before we integrate, we need to multiply this bracket out. So 2x squared minus x cubed is what you're looking for. So already I've got 2 marks here, one for the hashtag and one for the actual marking system. So if we integrate each bit individually, you want to add 1 to the power and divide by the new power. So add 1 to 2 and you get 3, and then divide by 3. Now remember your notation, we're now going into square brackets, 2/3 x cubed. And then going to add 1 to the power here to get 4, divide by 4, you get a quarter. So quarter x to the 4. Close your square brackets and put your limits at the end here, 2 and 0. Another mark for that. Next, I want to substitute the 2 into both places. So just like that. And then take away and substitute the 0 into both places. Now, because you're doing 0 cubed, which comes out to be 0 and multiplying, and 0 to the power 4 is 0 and multiplying, then I'm just going to put a 0 there. I would advise you to put a takeaway and write all this out again with the zeros in the place. So we've nearly got all the marks, we just need to sort out the last bit. So 2 cubed is 8, multiplied by 2 is 16 over 3. Take away 2 to the power 4 is 16 over 4. To do this, I think the easiest way is to change to a common denominator, so that's going to be 12ths. So 4 times 16 is 64 over 12, and 3 times 16 is 48 over 12. And if you take those away from each other, you get 16 over 12. Cancel it down, 4 over 3 units squared for your final mark. Okay, question 5. The line with equation y equals x plus 3 and the curve with equation y equals x squared take away 2x plus 3 are shown. So calculate the shaded area. This is really a question to test if you can work out the area trapped between two functions. Now, there's a couple of ways of doing this. The first way is to work out the area under the straight line. That's going to give you all of this area here. So if you integrate the straight line between 0 and 4, you're going to get all of that area. If you then integrate the curved part between 0 and 4, you will get this area. And then if you take those two areas away from each other, you'll get the area left over. That's fine. That is a way of doing it. It's not the way I'm going to do it. I'm going to do upper function minus lower function, and I'm going to do the algebra first. Now the way to find which one's the upper function is just to concentrate on the part between the limits, which is this bit here, and pick a point in the area and think what's higher up, the red bit or the black bit. Now if I'm looking at this, I see the red bit up here and straight down, the black bit's down there, so the red bit's the upper function. I can go over here and think about the same thing. If I go up here, the red bit's higher than the black bit, so the red bit's the upper function. So that comes first when you're doing your upper minus lower. So x plus 3 take away x squared, take away 2x plus 3. Now because you're taking away one function away from another function, and this one's got more than one term, we need to put it in brackets when you're doing a subtract. So multiply your bracket by the negative, and that's going to come to this. Negative x squared. The negative and negative gives you a plus. Negative times plus makes a negative here. The 3's will cancel out, and the x's will add together to leave you with that. So now if we just integrate that between 0 and 4, we're going to get this area. So write that out. We're going to integrate 3x take away x squared between 0 and 4. I'm going to integrate the first term first, so this is really 3x to the power 1. So add 1 to the power to make it a 2, and divide. So you're going to get 3 over 2x squared. So square brackets, 3 over 2x squared, add 1 to the power to get a 3 and divide by 3, so it's going to be negative a third x cubed between 0 and 4. Sub the 4 in and the 0, so subbing the 4 into both parts here, we get 3 over 2 4 squared, take away a third times 4 cubed, and I'll take away and do the same thing with the 0, but again I'm just going to put a 0 there at the end, because 0 cubed times a third is 0, and 0 squared times 3 over 2 is also 0. So for the last mark I need to sort this out. 4 squared is 16, times by 3 is 48 over 2. 4 cubed is 64 over 3. So common denominator of 6 is the easiest thing to do, so multiply up by the 3 and you get that, 144 over 6. Multiply up by the 2, you get 128 over 6. If you subtract them, you get 16 over 6, and then cancel it down to 8 over 3 to finish off. Okay, question 6. Last question here. Now what we need to do is we need to integrate 4x to the 5th plus 1 over x to the power 4. So there's no area involved here, so we need to remember a constant of integration. But before we integrate, I need to sort this out. I've got x to the power 4 in the denominator, so I need to take that up to the top and make it x to the negative 4. So that's what I'm going to do first. I'm now going to integrate both bits, so add 1 to a 5th and you get 6 over 5, and then we're going to divide 4 by 6 over 5. I'm then going to add 1 to the negative 4, so that's going to become negative 3, and then I'm going to divide by negative 3, so negative a third x cubed, and then plus c. Okay, to sort this first bit out, really 4 divided by 6 over 5, it's like this. 4 divided by 6 over 5 is really 4 times 5 over 6. So that's really 20 over 6, which can be cancelled down to 10 over 3. The rest stays the same, and you've got all your marks.